Okay, we're going to take a look at doing some operations with some exponents and some variables and dealing with some fractions. The first thing we're going to take a look at is this fraction here in which we are going to divide the two fractions. And the rule for division is to keep the first fraction the same. So we're just going to keep that the same. And what I learned in school, and there's a couple variations on the theme, is stay, change, flip. Other people learned keep, change, flip. There's a couple variations, but we are going to change the division sign to multiplication. You are allowed to do that as long as you flip the second fraction upside down. Let's write that as a 5 and not a 15. There we go. Now we're going to start to look at what we can factor. And then we'll talk about some canceling. On the bottom here I have this x squared minus 25. This is a difference of perfect squares. So I'm going to go ahead and factor it. Each one gets an x, and the 25 is the perfect square, the square root of 25 being 5, 1 plus, 1 minus sign. And then I'm going to write the second fraction like that. Okay, the next thing we're going to do is we're going to go ahead and look for some things that we can cancel. If we go ahead and look, there is an x plus 5 on the top and the bottom, so I'm going to go ahead and cancel those. There is an x on the top and the bottom here as well. I'm going to go ahead and cancel those. Remember, the x on the top does not cancel out with this x here because that x is stuck to a negative 5. That's what we call a binomial. It has two parts, so we can't cancel it. The 15 and the 5. 15 divided by 5 is 3, so I'm going to have 3 left on the top. And the y's are going to cancel. Remember, there's 1 y on the top, 3 on the bottom. We do some subtraction. That leaves 2 on the bottom, which leaves me with a 3 on the top. And you just got to be careful to really go through and look at everything that canceled out. What's left on the bottom? X minus 5 times y squared. Now, if you would like to multiply that out, you can and distribute, but you do not have to. That's actually what we call in simplest terms. Next, we're going to look at this fraction in which we have an equal sign, so we're doing some solving. So I'm going to first think about a common denominator between 3, 8, and 12. And you're going to have to do a little bit of thinking to come up with what the common denominator is. There's a couple of different ways we can actually approach this. I do it maybe a little bit differently than the book does, so this might give you a different approach. The common denominator is 24. And I look at each fraction individually. And I think to myself, okay, how do I turn that fraction into a 24? To turn an 8 into or a 3 into a 24, we do need to multiply by 8. So I go ahead and I multiply by 8 and I get 16x. To turn an 8 into a 24, I need to multiply by 3, and what you do to the bottom, you must do to the top, so I get 9x. To turn a 4 into a 24, you need to multiply by 6. So I go ahead and I do that, and I get 150. Now, here's the magic rule that will work. As long as your bottom numbers are the same and you've adjusted your top numbers accordingly to reflect that, you actually can then cross out your bottom numbers and pretend they don't exist, being left with 16x plus 9x equals 150. Now, if we go ahead and do some combining of like terms on the left-hand side, we have a 16x and a 9x. From there, you could solve as a fraction or as an equation normally, depending on what steps you have to do. I have to combine like terms, and then I have to do some division. And I'm going to get x equals 6. Now you can go back and go ahead and check that. You should come out with your solution. If you were to fill that into the original equation right here, you should come out with the equals on both sides. So it's never a bad idea to check and make sure you don't have any errors. The last kind of equation we're going to deal with is what is called a proportion, or it has two fractions that are set equal to each other. So let's go ahead and take a look. We'll do 3 over x plus 2 is 2 over x minus 2. Now, in order to solve these proportions, we do want to cross multiply, or multiply across. So when I multiply across this way, I'm going to get 3 times x minus 2, or 6, that was a bad 6, 6x minus 6, if you go ahead and do your sharing or distributing. Multiplying the other way across, I'm going to get 2, let's see if we can get the pen to talk a little bit better to the computer there, times x plus 2, or if we do our sharing, 2x plus 4. Let me write that 6 so you can see it. Okay, then we're going to go ahead and solve this just like we've been working on for the entire term. We're going to get all of our letters on one side. 6x minus 2x is 4x. We'll go ahead and give ourselves a little bit more space there. We'll add 6 to both sides. And last but not least, we'll go ahead and divide by 4. Now remember, when they do these equations, a lot of people get freaked out if they get decimals or negative numbers. There is nothing wrong with a decimal or a negative number. That's perfectly okay, so please don't let that scare you. In this case, I am going to get a decimal, 2.5, and I know that if I were to go back and check that, it would check out, which means it is the solution. So please don't be frightened of those decimals or those negative numbers. That's a look at doing some solving. This week we'll also take a look at some exponents in our second video.